World War II produced faster fighters, heavier bombers, and more powerful engines. But one German engineer was chasing something far more radical than speed alone. Reimar Horten believed the future of air combat would not come from adding more to the aircraft. It would come from removing everything that did not need to be there. His flying wing designs looked less like wartime machines and more like a glimpse of the future. World War II pushed military aviation toward a simple goal: more speed, more range, and more efficiency. Most engineers tried to reach that goal by improving the aircraft they already understood. They refined fuselages, increased engine power, adjusted wing loading, and accepted that the basic shape of an aircraft would remain the same. Reimar Horten rejected that logic. He believed that once designers removed the unnecessary drag created by the conventional fuselage and tail arrangement, they could build an aircraft that used less power more effectively and gained real aerodynamic efficiency. That is what made him different. He was not trying to perfect the traditional aircraft. He was trying to replace its layout with something more efficient. Horten's central idea was the flying wing. Instead of treating the wing as one part of the aircraft, he treated it as the aircraft itself. In practical terms, that meant reducing or eliminating the separate fuselage and tail surfaces that created extra drag without contributing directly to lift in the same way. This was not a visual experiment or a design made to look unusual. It was a direct aerodynamic argument. If more of the aircraft could be turned into useful lifting surface, and if the overall shape could be cleaned up, then range, efficiency, and speed could all improve, without simply demanding larger engines or heavier structures. That idea was difficult to execute because traditional control and stability usually depended on the very parts Horten wanted to minimize. But that is exactly why his work matters. He was trying to solve a harder problem than most wartime designers were willing to touch. What makes Reimar Horten such a strong World War II subject is that his work sat at the point where necessity and long-term aviation logic briefly overlapped. Germany was under pressure, fuel was becoming more valuable, and military aircraft needed better performance without endless increases in weight or complexity. In that environment, aerodynamic efficiency became more than a technical advantage. It became a strategic concern. Horten's flying wing concept offered a path toward that efficiency by cutting wasted drag and turning more of the aircraft into productive aerodynamic surface. That did not automatically make every flying wing practical or easy to build, but it did make the idea serious enough to matter. His designs were not just radical, they were built around a measurable aerodynamic purpose. That is why Reimar Horten deserves attention beyond the usual list of wartime aircraft designers. He was not simply chasing a faster fighter or a larger bomber. He was challenging the assumption that the conventional aircraft shape was the best possible answer for future military aviation. His importance comes from the fact that he treated the wing not as a component to be improved, but as the foundation that could absorb much of the aircraft's entire function. The real question is not whether Horten's flying wings looked unusual. They did. The real question is why one engineer became convinced that removing major parts of the traditional aircraft might produce a more effective machine than the standard designs that dominated most of the war. What made Reimar Horten's work so important was that he was not chasing an unusual shape for its own sake. He was pursuing a specific aerodynamic advantage. Conventional aircraft carried parts that were necessary for stability, control, crew space, and structure, but not all of those parts contributed efficiently to lift. The fuselage added drag, tail surfaces added drag, Junctions between major components created more aerodynamic penalties. Horten's answer was to reduce those losses by integrating as much of the aircraft as possible into one cleaner lifting form. In theory, a flying wing could deliver better aerodynamic efficiency than a conventional layout because more of the structure was doing useful work in the air instead of simply being carried through it. That was the foundation of his design logic. The problem was that the traditional aircraft shape existed for good reasons. A separate fuselage made payload and systems easier to organize. A tail gave designers a familiar way to stabilize and control the aircraft. Once Horten tried to reduce those elements, he was forced into a far more difficult engineering challenge. A flying wing had to remain stable, controllable, and structurally sound, without relying on the standard layout that most pilots and designers already understood. That meant careful control, surface placement, precise aerodynamic balancing, and a deeper sensitivity to how the aircraft behaved across different speeds and attitudes. This is what makes Horten more than a visually interesting subject. He was not simplifying the aircraft. In many ways, he was making the design problem harder in order to gain efficiency that conventional layouts could not easily match. That is why the Horten flying wing deserves serious attention in World War II aviation. It represented a different answer to the performance problem. Most late-war projects tried to improve what already existed through more thrust, heavier armament, or refined versions of familiar airframes. Horten was trying to change the shape of the aircraft itself so that the performance gain came from cleaner aerodynamics. This matters because it places him in a different category from many wartime designers. He was not simply asking how to make an aircraft faster. He was asking whether the accepted structure of the aircraft was still the best possible form for future combat and long-range operations. That is a much deeper question, and it is why his work still feels modern when compared to many other designs of the period. That is what makes Reimar Horten such a compelling engineering figure. His designs were not important because they looked futuristic. They were important because they were built around a clear aerodynamic argument. If drag could be reduced and more of the aircraft could contribute directly to lift, performance could improve without relying entirely on more engine power. The real question is not whether the flying wing was radical. It was. The real question is whether Horten had identified a more efficient path for military aviation at a time when most of the world was still trying to push conventional aircraft to their limits. Reimar Horten's importance becomes clearer when you look beyond the war itself. His designs did not become famous because they dominated combat in large numbers. They did not. Their significance comes from the fact that they forced aviation to confront a serious question. If the goal was maximum aerodynamic efficiency, was the traditional aircraft layout really the best answer? That question did not disappear in 1945. If anything, it became more relevant as aircraft grew faster, ranges increased, and engineers looked for ways to reduce drag without constantly adding more power. Horten's work matters because he was exploring that problem early, before most of the aviation world had fully committed to how the next era would be shaped. What makes Horten especially strong as a World War II engineering subject is that his legacy is based on design logic rather than battlefield myth. Many wartime aircraft are remembered because they were produced in large numbers, fought in major campaigns, or became symbols of national power. Horten's flying wings matter for a different reason. They represent an attempt to solve the efficiency problem at the level of the aircraft's entire form. Instead of treating drag as something to be reduced through small refinements, he treated the overall shape as the real answer. That approach placed him ahead of many conventional designers because it forced him to think about lift, stability, control, and structure as part of one integrated aerodynamic system rather than as separate pieces attached to a standard airframe. That is why Reimar Horten fits this niche so well. He was not simply another late-war aircraft designer producing an unusual prototype. He was one of the clearest examples of an engineer who tried to change the rules instead of optimizing inside them. His work stood at the edge of a transition in aviation history, where speed, range, and efficiency were becoming too important to leave entirely in the hands of traditional layouts. Whether every flying wing of the period was practical is not the point. The point is that Horten was asking a question that future aviation would continue asking long after the war ended. How much of the aircraft can be removed before performance actually improves rather than suffers? That is what makes this story so strong. Reimar Horten was not the engineer who built the most famous fighter of World War II. He was the engineer who challenged the shape of the aircraft itself. His flying wing designs showed that the future of aviation might belong not to the aircraft with the most parts, but to the one with the fewest unnecessary ones. The real question is not whether Horten's aircraft looked decades ahead of their time. They did. The real question is whether he was already building toward a form of military aviation that the world would only fully understand much later.